Okay, another MIT Integration B problem. This one from the video was difficult to tell if the contestants got the integral or not, but they basically were working a whole 4 minutes on it, so it seemed to be somewhat challenging to them. Let's go ahead and attack it and see what happens.
Specialize in science and math, original black men, busting thoughts that pierce your mental, the fierce, ripping your section. Vocal toe to toe, impeccable, splitting your back, son. Simple as addition and subtraction, black thought, the infinite relax one.
All right, so at first glance, it doesn't look bad. Well, maybe to some people it looks bad, but you know, when you really look at it at first glance, it doesn't look bad. And why do I say that? Simply because we have an arc sine here, and the derivative of arc sine is 1 over the square root of 1 minus x squared. So you're seeing a good relationship for u and du. So on first glance, it appears to be pretty straightforward. Now, that little substitution I just mentioned took care of everything but this x. So I guess what's going to make the problem maybe somewhat challenging is dealing with this x right here. But let's follow the thought. So we're going to say u is arc sine x, which means du is dx over the square root of 1 minus x squared. And so again, arc sine x would be u, du over the square root of 1 minus x squared would be dx over the square root of 1 minus x squared would be du. And the only thing we're missing, we have left is this x. So we're changing it to u, so we have to represent x in terms of u. And the deal is if u is the arc sine of x, and then x is sine u. So there's your x in terms of u. So when we do the substitution, so we'll integrate, and again, so x is sine u, and arc sine is u, so we'll say u sine u, and dx over the square root of 1 minus x squared is du. And let's see, I want to change variables. Let's see, what's u? U is the arc sine of x. Sure, let's change variables. So the arc sine of 0 is 0, and the arc sine of 1/2 is pi over 6. All right, so this looks like an integration by parts guy here. So let's say I do the integration by parts over here. So let's say w is u, which means dw is du. Let's say dv is sine u du, which means v is negative cosine u. All right, very good. So let's go ahead and do it. And so w times v would be negative u cosine u minus the integral of v dw, so the integral of negative cosine, so plus cosine u du. The integral of cosine is sine, so this is negative u cosine u plus sine u, to be evaluated from 0 to pi over 6. And when we do the evaluation, so I guess I got room to do it right here. I was debating doing it right here. Yeah, I'm gonna do the evaluation over here. So if I plug in pi over 6, so that would be negative pi over 6 times cosine of pi over 6, which is the square root of 3 over 2, plus sine of pi over 6, which is 1/2, minus, now I'm going to plug in 0, and so 0, cosine of 0 is 1, but that'll be 1 times 0, which is 0, and sine of 0 is 0. And so we're left with this expression, which we can write as negative square root of 3 over 12, say negative square root of 3 plus 6 all over 12. All right, that one looked pretty intensive, but it ended up being a fairly straightforward integral as well. I hope you enjoyed it. As always, we will see you next time.
Specialize in science and mathing, original black men, busting thoughts that pierce your mental, the fierce, ripping your section, vocal toe-to-toe, impeccable, splitting your back, son, simple as addition and subtraction, black thought, the infinite relax one,